All right, here we go, y'all. So, no, wait, that's not right. This is formulas. It changed. Boom. All right, here we go. So, guys, this is what we're doing today. This is the first of a 2-day process. This is going to go fast. So this is the first of what we normally do in a day that we've now broken into 2. So guys, today what you're going to learn to do is write formulas for complex salts. Now guys, contained in this idea is something that you know and something that you don't. So let's talk before we move forward. So guys, I would propose to you that there's 2 ideas contained in this idea, this topic. One is formulas and the other is complex salts. So guys, the first thing you know a lot about. How do I know that? Because none of you other than Harrison, who asked a great question, guys, none of you asked any questions as we were grading homework. That tells me that you feel super comfortable at writing formulas. You know how to write down the abbreviations, look up the charges, figure out the least common multiple, figure out the ratio, and write the formula by using subscripts. So guys, when you write down the word formulas, that's the stuff that's going on inside your brain. Those 5 things that you demonstrated a mastery of, unless you weren't here, and then you need to watch the screencast. Are we okay there? Okay, so guys, in order for you to then move forward, what we've got to do is we've got to talk about complex salts. Now guys, here's the deal. You actually already know about what makes a salt complex. It's just that we haven't told you that you were dealing with them all along in the last 2 units. So guys, all we've got to do today is connect something that you know, but we didn't really tell you you knew. We need to connect that to this idea of complex salts and then just practice on a couple and we're done. So guys, literally we've got about 15 or 20 minutes. You guys ready to go? Here we go. So guys, here's where we are today. This homework assignment, why is this not clicking? Oh, I'm still drawing dots. Do that. Abby, did you just laugh at me? Do you think if I just stand here and do this more, it's going to change anything? You know, they say that the definition of insanity is doing the same thing over and over and expecting different results. Interesting. All right. All right. So we're going to do this, and we're going to do this, and we're going to do this. Okay, so that worked. You guys want to learn about AP chemistry? Maybe not. Okay, so we're done with that. So we're going to open this. This is going to make for a really awkward screencast. All right, so if I may, if I go like this. Hey, I fixed it. All right. So guys, we connected with this idea that looking at the title for what we're doing today, we understand formulas, we need to understand complex salts. So guys, let's rally around this. What is this? It's the answer to your last homework. So guys, what we see represented here are formulas. And what is in your head is this rich understanding about how to write these. And then when we got down into the last 3 questions in the homework, which we breezed through quickly, we talked about the idea of what do these all have in common? What do these all have in common? They're all salts. They are a metal. Guys, don't miss this. If you're starting to chase butterflies in your head, make sure you don't miss this. These are metals and nonmetals bonded together. That makes them all salts. Are you settled with that? What they aren't is complex salts. Guys, these are all simple salts. And when we say simple salts, we mean salts that are a metal, and regardless of how many, they're a metal and a nonmetal bonded together. It could be 2 of the metals and 3 of the nonmetals, but it's still just a metal and a nonmetal bonded together. Those are simple salts. You guys good? Because they're about to get complex. So guys, what is it that makes complex salts? And this is where you want to start taking notes. Guys, the thing that makes salts complex are things called polyatomic ions. See, simple salts are monatomic ions, aluminum and oxygen, manganese and oxygen, which is the only one I remembered because Harrison asked about it. But guys, what you've looked at up until now are what are called monatomic ions. One kind of ion, could be a couple of them, but it's one kind of metal ion and one kind of non-metal ion. Now guys, we're going to talk about what are called polyatomic ions. So guys, let's be word sleuths and figure this out. Guys, what does poly mean? Poly means many, but many what? Many atoms. So guys, do this with me in your head. Many atoms bonded together, but they have a charge. So we're talking about many atoms bonded together that have a charge. Are you having the moment in your brain yet? Many atoms bonded together that have a charge. And guys, some of you are going, wait a minute. Not again. Some of you are going, wait a minute, didn't we draw a ton of those? And the answer is yes. Guys, this is actually lifted out of a homework assignment from a previous unit. Remember when we drew Lewis dot structures? And remember when we put those Lewis dot structures in brackets? Which ones did we put in brackets? The ones that have a charge. So guys, here's the deal. When you were doing this homework assignment and when you were drawing the Lewis dot structures for molecules, many atoms, polyatomic molecules, guys, when you were drawing the Lewis dot structures for these, you were drawing the Lewis dot structures for polyatomics. So guys, all we're going to do today is we're going to take these dudes and use them as ions just like all the other ions we've talked about. And other than that, the game doesn't change. So how are we going to keep this all straight? Wouldn't it be nice if we had a list of all of the polyatomics? Well, guys, in AP, you get to memorize these. Don't drop the class if you've already signed up. It's not that bad. But guys, in general chemistry, you get this list. When you lose it, there will be additional copies over there. When those run out, you can print them off of our website. But guys, these are fair game for the rest of the year. Everything that you do in this class is going to require that you have this in your possession. Oh yeah. Hey, so guys, do this with me. Looking at this side, there is a back, we'll talk later. Guys, looking at this side, in order for this to make sense to you, and some of you, your brains work like this anyway, but if they don't, you should probably work on this. Find the organizational structure to this. How do we know that there's an organizational structure? Because it's in a table. Guys, that's what tables do. Tables organize ideas. So let's find the organizational structure. How are these clustered together in the cells on the table? By what? By charge. So guys, do this with me. In the upper left-hand corner is the only ion that we're going to work with a +1 or a 1+ charge, and that is called ammonium, and its formula is NH4+. Then, guys, in the upper right-hand corner are the only ions that we're going to use with a +2 charge. They're mercury 1 and mercury 2, and their formulas are given. And then, guys, down below, you'll notice that this is where there's lots of examples. Bottom left, we have all of the polyatomics with a -1 charge, and you're given their names and formulas. In the middle, all of the ones with a -2 charge. Again, 2 minus or -2 is the same thing. Don't worry about it. Guys, with their names and formulas. And then on the right is the only one that we're going to mess around with a -3 charge, and that's phosphate, which is PO4. Okay, guys, with that said, you've got to be able to find these things. So let's start here with this ion in number 17. Find it on your polyatomic chart. Is it left, middle, or bottom right? Left. So we are looking for OH. Now guys, check this out. How do we know that it's bottom left? Because its charge is -1. Guys, you got to make these connections. Its charge is -1, so we know to look in the bottom left column, and then we just find OH. Because what is the name of OH? Hydroxide. So when you drew this ion, you were actually drawing hydroxide. So let's do that again. The next one that we've got is number 18. Is it bottom, middle, or left on the, is it left, middle, or right on the bottom? Left, because it's -1. Seeing how this goes? But now guys, be careful. What is the name of that ion? Be careful. There's two different NO polyatomics. There's NO3, which is nitrate, and there's NO2, which is nitrite. Which one is this? It's nitrite. By the way, guys, the 8 and the ite means something. 8 means more oxygens, and ite means less oxygens. Look in the center column and find sulfate and sulfite. Do you see how that works? It doesn't mean 2 and 3, it means more and less. Sulfite is 3 oxygens and sulfate is 4. So guys, ite means less, 8 means more, and so this with 2 oxygens is nitrate. Now guys, let's find the next one. Where are we going to look? Bottom right. How do we know? Because it's -3. Because you got to get the organization. And when we look in the bottom right, there's only one there. What's that dude called? Phosphate. Then guys, finally number 20, -2, which puts it in the bottom middle column. And then guys, we've got to find this, and it's 2 carbons, and it's 4 oxygens. And what is that called? That is oxalate. That is an oxalate ion. So guys, this now opens up for us a whole new range of possibilities, because now we have a bunch of different molecules that we can use as ions. But guys, the rules don't change. Write down their formulas, find their charges, find the least common multiple, figure out how many of each you need, write the formula. The rules don't change, it's just we're going to use these as ions now. So guys, let's talk about this. This is the only other thing you've got to keep track of. Wow. So these are what are called polyatomics. These are molecules with a charge. Now guys, there is one thing that you need to keep track of, and I would encourage you to write this down. If you allow your eye to scan through this table, you'll notice that most of these formulas end in, don't end in "ide." What do they end in? Sorry, I'm going a little fast. I'll ask the question again in a moment. So guys, if you allow your eye to scan through this table, you'll notice that most of them don't end in "ide." They end in "and," "ite." So guys, if you see an 8 or an ite, that is probably going to be polyatomic. If it ends in "ide," it's probably going to be an element: oxide, phosphide, sulfide, fluoride, iodide. But guys, there are 3 exceptions. Find the 3 ions on this polyatomic table that do end in "ide." Cyanide, hydroxide, and peroxide. Guys, those are worth writing down, or better yet, underline them on your paper. that will cause them to pop off of the page so that when you're looking at a chemical name, and if it's a hydroxide, cyanide, or peroxide, it will jump off the page. All right, so there you have it, guys. We're done learning new stuff. What we're going to do now is we're going to do exactly the same thing we did in the previous homework assignment, only we're going to do it for these with one exception. Guys, what you're going to find is that we treat these things, don't write this down. Guys, we treat these things just like any other ion with one exception, and it's all about parentheses. When we write their formulas, we're still balancing charges. Guys, here's the deal. If you only have one, and this is not going to mean anything to you, but I'll show you an example. If you have more than one polyatomic, you've got to put it in parentheses. And I'll show you why in just a minute. So guys, here we go. And then if you only need one, don't put it in parentheses. Let's look. So guys, do these with me. We're going to do 4 examples and then we're done. You really want to write these down. You want examples. Guys, I'm going to tell you right now, I make these look easy. Don't be surprised if they're hard. But you're not going to know until you're working on your own, but I want to set the stage for you. So guys, calcium sulfite. Sulfite. Okay, here's how to approach this. Just like the other homework. Step number 1, write down their formulas. So guys, calcium is Ca. And can we just get its charge while we're there? What is the charge of calcium on the periodic table? +2? 2? Okay. Now guys, check this out. The next thing that we've got, and please make sure you hear this, don't look over this. The next thing we've got is sulfite. How do I know that that's not sulfur? Because if it was sulfur, what would we call it? Sulfide. But it ends in ite. And if it ends in ite or ate, we're going to find it on that table. So guys, find sulfite. What is it? It's in the bottom. It's -2. Do you see it there? It is SO3. Guys, be careful. Sulfate is SO4. Sulfite is SO3. Now we need a charge. What's the charge of this thing? -2. Guys, at this point, here's what you do. Breathe a big old sigh of relief. Because at this point, it's just like what you learned before. What's the least common multiple of 2 and 2? 2. How many of these do we need? 1. How many of these do we need? 1. Guys, calcium sulfite is CaSO3, and you're done. Now, guys, let's talk about parentheses. Please don't write this down, but here's the deal. You will not do this. We only needed 1 SO3, and consequently, putting it in parentheses makes it wrong. And I know that's a non-issue to you now. It'll be important when you see when to use parentheses. You guys good on that? Let's do another one. Magnesium nitrate. So guys, here we go. Magnesium is element number 12. It's Mg. Its charge is +2, right off of the table. Now guys, how do we know that nitrate is not nitrogen? Because if it was, it would be nitride. So we find nitrate on the table. What is it? NO3. What's its charge? -1. Okay, so guys, let's pause for a minute. You guys all okay getting to this point? Now we need parentheses. Let's talk. Guys, what is the least common multiple of 2 and 1? 2. So how many 2's make 2? 1. We need 1 Mg. But now, guys, let's look at this. How many 1's make 2? Well, 2, so we need 2 NO3's. So, guys, let's write down NO3. But then the question is, how do we get 2 of those? And the answer is, you put it in parentheses and you add a 2. Now guys, at this point, I have people that ask me, why don't you just make this N2O6? Please do not write this down, but let me show you. Guys, if you could see magnesium nitrate, this is actually what it would look like. You've got a nitrate right here. Here's its valence electrons. And then you've got an ionic bond to a magnesium with a +2 charge. And then you've got another ionic bond that goes over here to another nitrate. Can you tell I've done this a time or two? So guys, this is what this looks like. You've got a nitrate on the right, you've got a nitrate on the left, and you've got a magnesium ion in the middle. So we've got to keep the nitrates together, because what this is telling you is you've got two nitrates. Two nitrates, and those two nitrates are bonded to one magnesium. Do you get the idea? That's why we keep them together and put it in parentheses. Questions there? 2 more to go, and then you're going to get some homework done. So guys, the next example we're going to look at, aha! Oh yeah! We're going to throw some Roman numerals in there for fun. But guys, these make these easier, right? All right. So I'm going to propose we don't even need to go to the periodic table, unless you don't know that nickel is Ni, but nickel's Ni. But guys, Harrison got us thinking about this just a minute ago when we were grading homework. Why does that Roman numeral make our lives easier? We don't need to go to the periodic table, but let's do, what would we find if we did for nickel? More than one charge. But guys, we don't need to look, because nickel is +3. How do we know nickel is +3? The Roman numeral tells us. Now guys, this is where this gets tricky. Hydroxide. Is that hydrogen? No, because that would be hydride. Is it oxygen? No, because that would be oxide. Guys, this is one of the 3 that we underlined on the table. It's OH. Big O, big H. Guys, it matters. Big O, big H. Now, what's its charge? -1. Now, guys, would you wait for a minute and watch me make a mistake? Watch. So guys, 3 and 1. How many of these do we need? 1. How many of those do we need? 3. Guys, watch. So we need 1 of these, we need 1 nickel, and then we need 3 OHs. Do you now understand why parentheses are important? Because guys, if we don't put the parenthesis, then that means 1 oxygen and 3 hydrogens. This means 3 OHs. Now do it with me. Can you even picture what this looks like? So guys, we've got a... Okay, I hereby officially don't like my board. All right, I'm going to draw it small. Do I dare do this? Yeah, I'm going to do it. So we've got a nickel with an OH up here and an ionic bond to an OH down here, and that's a molecule. And then an ionic bond to an OH down here. So guys, sorry it's sloppy, but that's the idea. You've got 1 nickel ionically bonded to 3 charged molecules. Those are the OHs. Do you kind of seeing it in your mind's eye? Let's do one more and then we're done. Remember how we started the day? Oh good, that got worse. That the only thing we can be assured of in this year is that things are going to change. Things are changing. Ammonium nitride, last one we're going to do. Guys, this is going to drive you crazy. So let me put you out of your misery. Write it down with me. Ammonium nitride. Some of you right now, including Matt, your eyes are scanning furiously around the periodic table to find ammonium, because up until now, the positive ones have always been metals on the periodic table. I know. Knappenberger to the rescue. So, guys, this is one of the few positive polyatomic ions. Guys, ammonium is NH4 with a +1 charge. Now, guys, here comes a big old curveball for you. What's nitride? It's nitrate. Oh, wait a minute. You mean we still have to think about the elements that are ions? Sure. Guys, it ends in IDE, and it's not cyanide, hydroxide, or peroxide. This is just nitrogen. Then the question becomes, which charge do we use? What did we agree on nitrogen? -3? So now, guys, we play the same game. I'm going to go up into the empty space. I'll go down. So, guys, 1 and 3. Those meet up at 3. How many of these dudes do we need?
3.
And how many of these dudes do we need? 1. So, guys, we need NH4, but we need 3 of them. Parentheses? Absolutely. And then, guys, we need 1 nitrogen, and this would be ammonium nitride. What do y'all think? You good? Bless you. So, guys, with that said, like Jasmine, I know that you weren't here last time, didn't? So, guys, if you weren't here last time and if you didn't watch the screencast, if you can do this, you basically learned everything we did last class period. So you may want to go back and sample it, but you may find that you can do the previous homework assignment as well. My strong advice to you would be this. If you haven't done the first assignment, do it first. But if you're in sync with what we're doing, go to assignment number 2. Guys, draw a vertical line down the middle of this assignment. So, guys, on the left-hand side of the line are chemical names that you're going to write the formulas for, just like we did up here on the wall. On the right are the formulas that you're going to write the names for, but we haven't done that yet. And so, guys, what I want to do... How many are there? 38. Odds or evens? Evens? All right. Let's do the evens. Guys, I would propose to you that if you can do 19 of these, 38 divided by 2, you can probably do all of them. So when we get together on Friday in class, in order to be able to say yes, that you're done with the assignment, we're only going to hold you accountable for the evens. Guys, if you'd like to do them all because you need more practice, that's fine. Because I think if you can do 19 of them, you can probably do all of them. So let's do the evens for Friday. But guys, I need to mention something to you. When you look at the answers, when you look at the homework answers, guys, you're going to see something a bit confusing. Here. Guys, when you look at the homework answers, you're going to see all these chemical formulas, but then you're going to see things in parentheses like Ng or S or I. Don't worry about it. We will talk about, we were going to do that today, but I'd rather just have you move forward and get to work. We'll talk about it on Friday. Don't worry about the things that are in parentheses next to these. Frankly, it's whether or not they dissolve in water, and we'll talk about it later. It's all on the back side of your yellow sheet. We'll mess with it on Friday. So guys, for now, we're going to do the evens in the left-hand column, and we're going to turn those in on Friday. And so guys, again, if you haven't taken the test, I'll see you tomorrow or Friday after school, or make other arrangements. And guys, the rest of the time is yours to get some of these done. I'm not going to leave these on the wall because I think you're going to be better served doing them without the answers. Go